too. I don't know. Here's the plan. We have a derivative lab. It's going to be 25 points, summative. No, it's not due Monday. It's due Wednesday. Well, I'll give you the whole thing, so it's just patience. Now, what we're going to do is we're going to take the 25 points and whatever you get and multiply by 4, and it's going to be a regular score. It's not going to be on the P scale. Now, this is a lab report. It's professionally done. You're going to be going to college, if not next year, the year after, and you're going to have to do something like this in your college classes. In math, probably. Some sort of project. They're going to go over the product. They're going to hand it out like I did that, or maybe even less explanation, and you're going to have to be able to do it. So this is practice for that. Okay? Now, it's due Wednesday. Tomorrow is a crazy day because it's a shortened day because we have Pep Fest. But tomorrow I want to show you the Inspire calculator because you all have access to it. It's free for a month, for 30 days. You just go to TI's website and download it. And when you see what it can do, the pictures you see on here were all done with an Inspire calculator. That enables you to take your pictures that you have on the Inspire calculator on your computer and put it into a report. You don't have SmartView. I don't have SmartView. So even though I have beautiful pictures on SmartView, I can't put them into the report. I mean, I can here at school, but that's it. On my home computer, I cannot do that. So this is another way. Plus, I think if you look at those pictures there, they're much nicer with the Inspire. Plus, there's other really cool things that I'll show you tomorrow. There's just too much to do today. So you should be writing. Now, when you do this lab, and we probably should look at the last page. Does everybody have a copy? Because I got some extras here. Okay, make sure you have one. If you look at the very last page, it talks about what should you report, instructions for your report. And then, of course, my favorite cartoon at the bottom. Oh, no, that's not my favorite one. The ones with the guy on the psychiatric couch that says algebra on a shirt. That one's funny. Okay. I don't like 4 students in a group. I wish we had changed it, but since it's written, I think we have to go with it. The reason why I don't like 4 students in a group is because somebody will sit and do nothing. That's a problem. If all 4 of you do it, that's fine. Really, everybody should be doing all parts of this. Then you get together and you combine and do one report. That's really what you're supposed to be doing. This is not divide and conquer. But unfortunately, I will see that. Okay, you can take all the notes you want on this handout, but if you turn this handout into me, I'm going to hand it back to you and say, you need to hand in a report. It has to be on a totally new piece of paper. This is formal. This is what you're going to do in college. You would never write on here and hand it in. You type it up. Cover page would be nice. You should be doing some of those things in your science classes. So it's like science. Should be clearly written and put together just like you would a formal lab in science. You should include complete sentences. And I'm going to see if I can get us into the lab on Monday. Because Monday, Mrs. Erzman and I are taking a workload day, so we're not going to be here. You have the hour to work in your groups. So I guess I highly recommend. Well, I guess you could work with other students in other classes. It doesn't really matter, but you won't have anybody to work with within my hour on Monday. So we have that on Monday, and you should be able to get it to me by Wednesday. You should include a sample calculation for each major calculation, like finding slopes. And we're going to do some of that. I'm going to show you what your calculator can do to make this less tedious. Okay, if you do not follow these directions, your report will be returned to you to make corrections. Okay? So we're going to go through this right now and make sure we understand it. So we were asked to read this, even if you didn't understand it, because then you've seen it before I start talking about it. But we are where we are. Okay, so my goal here in this lab is to figure out what a derivative is. And we're not talking about a financial derivative. It's the derivative of a function. And we are going to do lots of things here. We're going to examine the slope of a secant line, and I'll review what that is, because I'm sure you might have forgotten what that is. So we're going to do this geometrically, looking at the slope of a line. We're going to use our calculator. It's called n-derive. We're going to use that function. And we are going to do this algebraically. That's the part you're not going to like. So there are 3 approaches for each problem: geometrical, algebraic or analytical, and with a calculator. I'm not the author of this, but I tweaked it so at least was more readable than the original one, which wasn't, well, it was okay. Okay, so that's our goal. And before we do that, we better know what a secant line is. And here's where we start talking about it. You learned in geometry that the slope of a non-vertical line is y2, oh, I don't like that one, minus y1 over x2 minus x1, right? First year algebra. What do you have to have, though? You have to have 2 points, right? That's the problem. Because we're going to try and find the slope of a line at only 1 point. So most of the functions have the property that if we pick a point on the graph of the function and zoom in, you will see a straight line. So when I look at my graph here, and let's go ahead and review for a second. Back in geometry, when you had a circle, and you drew this little segment, do you remember what that was called? No? Starts with C. It's a chord. Okay? If you drew a line that cut through the circle, that was called a secant. And if you had a line where it just touched the circle, what's that called? Tangent. So what we're going to do, and I can do it much easier on the Inspire actually than I can on the 83, but I'll do that tomorrow, is we're going to take a secant line and we're going to actually kind of drag it around. You're going to look at points to get to a tangent line. A tangent only touches in one place. So this green line right here, that's my secant line. And you need to know that because I'll refer to a secant line all the time when we review derivatives. So all a derivative is the slope of a tangent line. But I only have, unfortunately, 1 point. So here's my x value. I would like to do the slope of the tangent line right there, which is obviously a negative slope where the secant was positive. But what I'm going to do is I'm going to take a point on this graph, and I'm going to drag it closer and closer. What happens to this distance between here, which we're going to call h? What happens to that distance? It's getting smaller. So guess what we're going to do? We're going to take a limit. That's your throat. Okay. And I'm going to drag it closer and closer until the points are almost on top of each other. If they are on top of each other, so if I did do that, if I did f of a plus h minus f of a, that's the difference in the y values. The difference in the x values are a plus h minus a. If I simplify that, that looks like f of a plus h minus f of a all over what? What happens in the denominator? What's left? H. And you remember we took limits and we let h do what? Go to 0. That, by the way, is an answer to one of the questions. I didn't do it in the other class, but I didn't. It's here. Now, I'm videoing this, so if you need to go back, and watch the video again, especially if I go too fast, you have to tell me if I go too fast. But watch the video again. And that's what you're going to do. What happens if you put in h equal to 0 here? What do you get? If h equals 0, you get f of a minus f of a over h being 0. Guess what? We get 0 over 0. So we can't ever get to that point because there's not 2 points when I'm trying to write the equation of find the slope here between these 2 points. It's the same point. You can't find the slope between the point in itself. It doesn't even make sense. But we can get it really close, and we can find the limiting value. Okay, you guys? You're not going to mess this up, are you? Okay. That's my goal. So I kind of answered question 1. I'm let you figure out what I answered there. So we're going to look at this function right now. So now you're going to need your calculator. Now, if you haven't done any zooming, it's a possibility. So in y equals, I'm going to put that function. And I'll give you a chance to enter that. And I don't have any more calculators. And this is not going to go away. Doing this f of x plus h stuff is going to be there for a while. And it's going to be on the AP exam. You'll have to recognize it and say, oh, that's a derivative. I know an easy way to do this. Okay, does everybody have x cubed minus 6x plus 3 in their calculator? No, are you in the pretty print? You have to go down. So that's the problem with the pretty print. It tends to put everything up in the exponent, which that's a problem. If you don't have the new operating system, I can get that for you too. But if you're at the 83, there is no new operating system. So you're going to put this guy in there, and everybody needs to do everything. Oh, this is, the Inspire will act just like that. Actually, it's easier than the 89, and you can get the software for free for a month. So if you know how to use that, you know how to use an Inspire. It's actually easier. Okay, and somebody's already ahead of me and graphed it. Good job. All right. Okay. My window, I want from -3 to 4. -3 to 4. I'll go back to that window. And then the question is, what are the y values? Because if I graph this right now, I'm missing part of my graph. Actually, I've got the part that I need. But I would really like to see the whole thing. If you're on the exam and they ask you to graph a function and you copy that graph down, you're not going to get the points because it's wrong. Now, you could play with it, or you could say, well, I'm going to go from -3 to 4, so I'm going to look at my table. So second table set, I'm going to start at -3. I'll count by ones, and I'll look at my tables because that will tell me what my y values are. So at -3, it's -6. It goes up to 8. It goes all the way up to 12. So I got to include -6 and +12. And if I go to 4, it gets really big. Fast. I mean, to me, that's big. And I don't want to use 43 for my upper limit on my screen because everything will be too squished together. So you can try it, but it's not going to work. What is what? Ask. I don't know. Let me see. I don't know. I don't know if there's a way to change that at all or not. Okay, so we're going to take our window and we'll make the y's go from -10 to 12. And you'll get a pretty good picture. Much better picture than what I just had. There you go. Now you can see what it really looks like. That's what you would put onto your exam. Do you want me to show you the window again? Let me take a picture of it. So there it is. Whoops. Okay. And what we're going to do is we're going to zoom in on 1, -2. Actually, I'm going to add a page. This is the reason why I don't want you writing in your report, because you see it gets kind of messy. So we're going to add a page so I can put all these nice things on there. So I have room. And we're going to zoom in on 1, -2. So here's what you do. You trace to 1. You guys know this. I've been through this, but you might not remember it. You can just type that in and press enter, and it'll go to 1, -2. There it is. Now, have you zoomed in before? I want to zoom. Now, some people in the last class didn't zoom in at that point, so they didn't get the right answers. You want to keep your cursor right near that point at least. So we're going to zoom. We're going to zoom in. Yeah, 1.02. I mean, you could maybe move it a little bit. 1.02 I like better, actually. And then just press enter. And we're going to keep zooming in until it looks like a straight line. And I took my ruler, wherever I put it, and I actually checked it out. Where did I put it? That does not look like a straight line. So trace. It's nice if you keep putting it back on 1 so you'll stay centered there. You don't have to, but you need to be near 1, -2. And so I'm going to zoom in again. 1.002, that's good. I mean, I literally were at 0.5. Okay, that's way far away. That doesn't look straight either, does it? We're going to zoom in, so you press zoom. You press in. And I'm going to trace and get myself back to 1. That's not straight. More than one time. You want to make it really straight. Did I leave my ruler anywhere? Oh, no wonder I couldn't find it. Okay, zoom in. Now, when you zoom in on Inspire, it's way easier. It's so easy on an Inspire. Okay, you guys probably think that's straight. Let's see. That's not straight, is it? I mean, you literally want to have it really straight. So we're going to zoom in again. Make sure you're close to 1. You know, if you're not, you can move your arrow so it's close to 1. I still think there's a curve. One more time. It's got to be straight. What you're doing is you're just like looking at a microscope. You're trying to go way deep, and you want to get really close. Now, that looks pretty good. When in doubt, put a ruler there, a straight edge. That's pretty straight, isn't it? If you do it let me do one more time? Yeah. Okay. If you do it too many times, the graph will become corrupted. But that's okay. I think we're okay for one more. Well, I don't think it's going to happen here. Now you're starting to get into the pixels. You see there's a little jaggedness to it. Okay, so I'm going to start it. I'm going to trace it at 1. Now I'm going to show you some. Uh-oh. I think I'm in too close, yeah. Trace 1. See, that's the problem. Okay, so I'm going to have to graph, and I'm going to have to zoom back out. I got too close. Now I should be able to do it. Trace, I hope. 1. Now I start over. Weird, I didn't have this happen before. Trace. Oh, guess what? I got too far away, didn't I? Let's look at my window. That's the problem. X max, I want to be at over 1. I didn't zoom too much. Well, I did. I got off. Now, if I trace it at 1, I should be able to get there. There. Now, I'm not getting the y values. I want to see -2. I want to be able to see it. So I better do one side of -2. I had to think for a second. Whoops. It should work now. I just want to be able to see it. Okay, so trace. So that's the problem when you get too close. Okay. It's way down there. Now, you just want to go one place to the right or left. It doesn't matter. I'm going to go left. And there it is. And I'm going to take this picture over here. I don't know why this is not working, but it's not. And now I want to find the slope between, I'm going to show you how to do this, between this point, so it's -1.9990. Yours is going to be different, by the way. That's the change in the y's minus a -2 divided by the change in the x's. Now, don't just blindly look at the numbers here. It doesn't matter. You just want to be really close. Are those really close together? Is that really close to 1? Yes. In fact, in your mind, what's the difference between these two? It's nothing. It's 0, right? So I got my 0 over 0. I'm not at there, though. I'm not at the point. I'm really close, which is what we've been doing. Okay, well, you know what? That's a lot to put in my calculator. So this is really cool what I can do here. This is now stored in my calculator. So if I quit, and I'm going to clear this out here. We don't want to look at that yet. And I type in X, and I press Enter, that's the X value my cursor was last at. And if I go alpha y, and the y is above the 1, I can't see it, but anyway. That's the y value. So what I'm going to do is type in my slope formula and let the calculator do all the work. Okay, do you see where my x's and y's are? And you know the slope, right? So I'm going to clear that out. Now, because this is not going to be a nice fraction, I have to use parentheses. Some people didn't. Okay, so it's y, alpha, y, minus, I'm going to let the calculator do all the work, a negative 2. That's my numerator. Alpha, 1. Just type it in. Okay, do you see that's the change in y up there? Now I want to divide that by the change in x. So it's going to be parentheses. If you don't use parentheses, it's not going to work. It's x minus 1. X is the x, same old x. You can do alpha x. I think there's an alpha x, maybe not. Okay, you could do that too, it doesn't matter. It has that x and y value. If you haven't moved your cursor at all, it's stored there. And it's going to do this. What do you think I'm going to get? It's 0 over 0, in effect, but it's not, because you're not at 0. Ooh, that's even better than I got in the other class. Because remember, 0 over 0 is indeterminate. I want to find the limit.
Oh, so it's finding the limit.
I want to find the limit. It's always stored. When I go back to my graph, okay, guys, if I go back to graph, and I press trace, it's wherever I left off. Wherever that cursor is, it stores it automatically. Now, if you want to store it someplace else so you keep it forever, you'll have to actually store it into A, B, C, D, or wherever you want it. Because the minute I move my cursor, that point is gone. Okay, see, I've changed it right. So if I go in, and you got to be really close, because remember, we're trying to get the slope of the tangent line. So we have to use 2 points. But I want to be so close that I hardly tell it's 2 points. Now, if I quit here, remember, it's 0.9995, right? And if I type in x, it's the last x I was at. So you really want to know that, because if you're trying to find the intersection of 2 curves and you want to use that point of intersection, you want to be able to use that. You don't want to be typing that in on the exam, because first off, you probably do it wrong. I know I will. Okay. Well, we just did that's the geometrical part of zooming on this lab. Okay. Oh, I'm on the wrong page. Hang on. Okay. Now, we're going to turn the page, and there's a little chart here. Now, I made the chart in Word. It's not hard to make. Actually, the Word document's there. You could actually take some of the, you could go into my Word document and copy it. I'll make sure it's up on Schoology. I'm not positive it is, but I think it is. But let's do this little chart. So I'm going to go back over here, and we're going to look at this little chart right here. So I'm just going to try to find the slope. So here's my curve, and here's my point. So it helps to visualize this. This is 1, negative 2. And I'm going to find another point on the curve, and my distance from this point is going to be 0.3. So I'm going to travel 0.3 to the right, and I'm probably over here someplace. So what's my new x value? This distance is 0.3. So what's my new x value? 1.3, right? What's the y value? I don't know, but it's f of 1.3. Okay? This is confusing, I know that. But I want to find the slope between these 2 points. That's what the table's for. So I need to find f of 1.3. How do you find the slope for that? Well, it's just slope. F of 1.3 minus f of 1, if you want to write it out like that. It's the change in the y values divided by the change in the x values, which is 1.3 minus 1. And guess what? I can just type this right on my calculator. Can I find f of 1.3? Pretty easily. I'm going to make it even simpler than that. But first, let's figure out how we get that. And I don't even simplify that, but I do know that's 0.3. It's the h value. These are the h's. So I'm going to go back to my calculator, and I want to find f of 1.3. Okay, so I'm going to change my window back because it's all messed up now. And we went, what, negative 3 to 4, right? And then I went negative 10 to 12. Okay, there's a lot of ways to get f of 1.3. You could trace, this is the easiest way, and type in 1.3. There it is, negative 2.603. I like the way that worked before. It used to stay there. You could go second calculate and get the value at 1.3. What's the difference? The same thing, really. Or, this is cool. I'm going to get out of the graphing screen. Because if on the graphing screen, I have to have the right window. As we found, I ran into trouble because I didn't have the right window. I'm going to clear that out. Now, you have to know how to do this. This is a very important skill on your graphing calculator. I want to pick up Y1, the vars. We are not doing any of those things. That's for programming. We're not doing that. We're going to go to Y variables. We're not doing parametrics or polars, so we're always doing functions in this class, so you don't have to worry about it. Press enter, and there's Y1. It's like the old Macs. You had to go through the pull-down menus. You couldn't just type it in. Now, if you're on an 89 or Inspire, you can just type in Y1, which is much nicer. Okay, that's function notation. This is f of 1.3. I want to vars. You have to be able to pull up Y1. And I go to Y variables, and I go to function, and there it is. All your Y's are there. Now, some of you have the new operating system. And if you have an 84, I can upgrade it. Now, I've done the var thing so long, so many years, that it's actually faster for me to do that than it is for me to use shortcuts. The shortcut is alpha, and then the trace, and there's Y1. But you have to have an 84. You don't have it on the 83s. I don't know why they didn't. I suppose there's not enough memory. Of 1.3. And it's so forgiving, I don't need that parentheses. There it is. But there's even a better way. Okay? There's even a better way. I can actually type this formula of slope right into my calculator. Now, it's not pretty print. You have to have a parentheses here and a parentheses there, and then you're going to hit divided by, and a parentheses here and a parentheses there. But let me show you the beauty of this. Because you really want to make this lab not so tedious, because some of these calculations are tedious. So I need a parentheses. Okay, ready? How do I get my Y value? Remember? Vars. And then I arrow to the right, and basically I press enter. Enter, and I want that at 1.3. 1.3, close your, now you have to close your parentheses, minus, I need f of 1. I could put the 2 in there, or I could, well, you know what, well, it's a negative 2. Do you want to put negative 2, or do you want the calculator to calculate it? Okay, vars, because it actually can see slope then. And then I want to pick up y1 of 1. Hopefully you see the slope there. Close the parentheses. So that's the change in y in the numerator. Then you have to hit divided by, and then parentheses, because that's order of operations, 1.3 minus 1. That's going to give me my slope. What should we get? We should get something pretty close to negative 3. No, sorry. I'm thinking in the wrong place. Negative 0.01. Yeah, that's right. The shortcut is alpha trace. Yeah, not everybody has that. Notice I'm not in pretty print mode. Okay, so we have the first value for our chart, negative 2.01. What's my new h value for the next one? What h is though just 0.2. Okay, watch this, because this is cool. I don't want to type all that in again. You know I'm lazy. Now, if you have the new operating system, you can just arrow up. But if you're with an 83, you have to press second, enter. Now you can go in and edit this. And all I have to do is go up here and over and make that a 2, and go down and over and make that a 2. That's it. It's pretty slick, actually. All I did was second, enter, and then it recopies that line above there and allows me to go and change numbers in there now. The next one you're going to put in is 1.1, so you can change the 0.2 to 0.1. But this is all I'm going to do, because you got to do something. Negative 2.36. So I'll put that in my table. Nice. Now, these h's aren't very small. And I was thinking of changing the lab so that the h's would be smaller. Then you could see it get closer and closer to that slope. Okay. Next part. There's a hole in the slope equation, not in the graph. But we only want the limit anyway. Okay. We're going to do the analytic solutions, one you're not going to like. Okay, so we zoomed in on this. Now, by the way, this chart is only for this cubic function. You have other functions to investigate, but you don't have to do this chart for those. There are 3 things you're going to do. The geometric approach, we zoomed in. Then the analytic, which we're going to do right now. Get you set up with it. I'm not going to do it. And then the last one, which is with your calculator. And that will take us probably to the end of the hour. And you'll like that, because I'm going to show you a couple things with your calculator that are really cool. You'll learn more things what your calculator can do. So let's do this analytically. So my function, f of x equals x cubed minus 6x plus 3. And the point I'm trying to find, I want to find the slope of the tangent line there. So it's right in here. That's what I want. Okay, girls? Ready? So you know how to do this. I'm going to go a certain distance over here. Let's just go over there. We'll call that h. Now this is at 1, negative 2. Where am I over here? If I go distance h to the right, this is what? 1 plus h. And then this is f of 1 plus h. How do I find the slope between these 2 points? Between this point and this point, we know how to do that, right? It's old stuff. This should look familiar. It's f of 1 plus h minus f of 1, really, all over 1 plus h minus 1. Can we simplify that? Hey, you guys, can we simplify that? A little bit. It's f of 1 plus h. Well, f of 1 is what? Negative 2, right? We're doing the analytic problem, the algebraic one. And what happens to the denominator? It's over what? H. Okay. What's going to happen to this point? I'm going to put this point right here. What happens to h as I drag this across down the curve? H is getting what? Bigger or smaller? H is the distance, the x distance between this blue point and the black point that's fixed. It's getting smaller. So guess what we're going to do? Why have we been doing all this? Because we're going to take a limit. And we're going to let h do what? Go to 0. Should look familiar. We've been doing some of this, haven't we? This is a derivative. A derivative is, I don't know why they call it a derivative, but it's the slope of the tangent line. So what we're doing is looking at this geometrically to find the slope. We're going to do it algebraically, because we're going to do a lot of stuff with algebra. And then you're going to use the calculator. You need to be able to do all of those. Okay, so my function was that not so nice function there. So what am I going to do with the 1 plus h? This 1 plus h, I'm going to put it right in there, right? Oh, and there. So you're going to substitute 1 plus h into our function. Now I'm writing so big, I'm going to have to hopefully remember what it is. Okay, so it's 1 plus h cubed, right? Minus, isn't it minus? 6 times 1 plus h plus 3. That is this piece right there. And then you're going to do minus a minus 2. And we're not going to like the algebra, are we? Are we? Because you have to do what with that 1 plus h? You have to cube it all over h, and then you're going to take the limit. I know some of you on your worksheets skip these problems. I said, don't do that. Why do you think they're there? They're there because we're going to do them. Do you remember how to cube a binomial now? Probably not. You'd have to go back to your old notes, but I'll go ahead and write it out, but I'm not going to do it for you. And also, do you remember I promised that that negative 2 is going to go away? It's always going to cancel if you did it right. So what is a plus b quantity cubed? It's the binomial theorem. And we get the coefficients from Pascal's triangle. So it's 1a cubed, and I'm actually going to write this b to the 0 power, because those exponents have to add the 3. And does anybody remember the next coefficient? 3. Remember, it's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. What's the fourth one? 1, 4. Yeah, just add those. 6, 4, 1. It has to do with combinations, by the way. Remember we did combinations and permutations? It's really actually pretty cool. Okay, so it's a squared, and the b's are going to go up. These have to add to 3, plus 3. Then it's ab squared. Put the 1 in there so you see it's 3. Plus 1, and it's a to the 0, b cubed. There. I'll let you do that. I'll let you put the 1 and the h in. Okay? I know, you don't like the algebra, do you? Figure out what a and b are. Then you can do it. Okay. Algebra's not so bad, but there's a lot of bookkeeping. Now, if you have an Inspire CAS calculator or an 89, then you could just type in 1 plus h quantity cubed and expand it, and it'll give you the answer. They're nice. I have some. I do need them for my first and fifth hour. You can borrow them during the overnight as long as I get them back. They do everything. It'll give you what it is. Because honestly, what is my goal here? I mean, one of my goals is to remember to be able to do this. That's true. But if I don't really care about teaching how to cube that, I don't really care. Why not use a CAS calculator? What do you think engineers do? Do you think they do things by hand? Jack? Do you think they do things by hand? No, they don't. Everything's done with Mathematica. And if we had Mathematica here, that would be nice. But, I can never get into the labs. That would be even better for you, getting you ready for college. Because they will take you into the lab in college and have you use Mathematica. Unless it's an easy program. I've never used it, but I know they do it. Okay. Now, this is the analytic calculation for slope. So first we zoomed. We made our points really close together. Then we did this algebraically to see what's going to happen. But your calculator also will do this. Now, the calculator basically is doing our zooming problem, but you don't actually have to do the zooming. It kind of does it for you. And that's called n-derive. A little bar here. And now I'm using the old way of doing this. Tomorrow I'll show you pretty print, unless I have time today. But the syntax, does I have to have that there? I don't remember. Now, on the 89 calculator, because I've got some people that are using those, you just type in n derive, because it's not on your calculator as a button to push. And then you put in your function, and then you have to say, I want the slope. Now, slope is a ratio of rise to run, right? It's not just the rise. It's rise over run. So I want to see how the y changes if I change the x. Well, you'll get to multivariable calculus, and you might have want to see how the y changes if I change y. I mean, there are different things you can do. But for our classes, we have to tell the calculator that our variable that we're going to compare the rise to is going to be the run, which is x. It's just the way it is. And then at what point, which is a. Now, there's that way to do it, and then there's some other ways to do it, too, on our graph. So let's take a look at those with our calculator. You're going to like this part. Oh, and I didn't do this other thing either. Let's go back to my graph. There's a draw function. And I want to trace it. I want to make sure I'm in the right place. I want to be at 1. Okay, I'm going to draw the tangent line. So I'm going to go to second. Now, you guys don't know where draw is, do you? See where program is? It's right above program. Now, that's how you get vertical lines, because a vertical line is not a function. So I'm going to do tangent, 5. And I want to be pretty close to 1. I don't think I can type it, but I can try. Maybe it will. We're still doing the same function. And there it is. Nice. Guess what it gives me? It gives me the equation of the tangent line. Okay, so what I'm going to do is clear this. I've already drawn it, and it won't go away unless I clear it. So I'm going to do, and I'll repeat it. Second, and then program is draw. So I have to clear it. Okay. I don't even have to be in the right place. So we're going to go second, draw. And I want a tangent line. Is everybody with me? They all do this. 5. But you want to tell it where you want it to draw the line. I want to draw the line at 1. Now what I can do on my inspires, take this point and drag it, and you can see how the tangent line changes. I typed in 1, and I press enter. It should go to that point and draw the tangent line. And they give you the equation of the line. That's kind of cool. But there's another function on your calculator which will give you just the slope. Now, I would like to get rid of that. Somebody said, how do you get rid of it? So you have to go second. You got to go back into draw. You want to clear your drawing. Okay, while I'm on the calculator screen, let's do this. Let's go to second, calculate. You know, that's where you found your values, your zeros, your intersection points. You know how to do all that, right? If not, we're going to learn. But this number 6, you know how to do 1 through 5 up here. But 6, it kind of looks like a delta y and a delta x, doesn't it? It's dy and dx, meaning that the change in y is really small. So we're going to press 6. I attempted to push here, but I can't. And where do I want to find the slope? That's just slope. I want to find it at 1. There it is. So dy dx is a symbol that we're going to use for slope. If you really do this lab, section 3.1 will be a whole lot easier. Okay, the problem with this is I have to have the right screen. Okay, you guys? If I don't have the right screen, I can't do it. If I try to do the slope at 8, which is beyond my window, it will give me an error. So I'm going to go second, calculate. Let's do the slope at 8. See, I've got to be in the right screen. So I don't like that. So there's another way to do this. And I gave you the syntax, but I'm going to move this so we can see it. It's this n derive. And it's going to look a little different if you're on a pretty print. You might want to go to classic print. But it's going to look nice, actually, another one. So I go to math. This little arrow here by 7 means there's more. You will memorize where this is. It will become automatic. N derive. And there's another one, the other one, FNINT, you'll learn what that is too. So n derive, this is actually fairly cool. Press enter. This is going to give you the derivative at a point. So I need to put my function in there. I never type it in. I always have it in Y1. So I'm going to go get it out of Y1. Because there's too many parentheses half the time and I mess up. And then I have to do a comma. Everybody see where the comma is? And then X. And where do I want to do this? At X equals 1. X is this X right up here. You could do alpha X. Now, to help those people who have the new operating system, let me change my mode, because I got a few minutes here, to go back to Pretty Print. And this is the printing that you're going to want yours like this, actually. Whoops. Okay, there's Math Print. Second quit. Okay, so if I go to Math now, and there's a shortcut for this too, and I'm going to go down to 8, because I know where it is. It looks different. Okay, you just have to put the X that's there. Put the X in. Here, you got to get your Y1. But this is the way it's, whoops, bars. Guess what I forgot to do? I forgot to go over. And then you arrow, and you put in 1. That's what it's going to look like for all of us when we do it paper pencil. So you have to put in this, and this, and that. Yes. Same button. It's still in the menu, and arrive. But now, if you guys are in Pretty Print, then you have this other option. You go to alpha. Okay, guys. Shh. Okay, guys. Let me show you one list. Guys, not quite time. It's close. That's all your fractions. If you have the new operating system. If I go alpha, this one, whoops, that gives me 6 sigmas, which you don't know about, but it does a change of base for you, for logs. So you can do log base 2 now, which is pretty cool. So, and derive is right there. It's 3. And it comes in that beautiful form. So you can do the shortcuts, or you can go under math, second quit. It's going to give me an error. And you go under math, it's still end derive. You go down to 8. You will memorize where it is. There it is, 8. Okay? I should have your partner quizzes done by tomorrow. The plan.